We are calculating the Laplace transform of different functions, and we have proved that the Laplace transform of 1 is 1 upon s, that is, Laplace transform of 1 is 1 upon s. This we have already proved. In the similar way, we calculated the Laplace transform of t, and then we proved that the Laplace transform of t is equal to 1 upon s square. This we have proved. Similarly, we calculated the Laplace transform of t raised to power n. Laplace transform of t raised to power n, we have proved it is equal to factorial n upon s raised to the power n plus 1. This we have already proved. In the similar way, we calculated the Laplace transform of e raised to power at, and we proved that Laplace transform of e raised to power at is equal to 1 upon s minus a. Then we calculated Laplace transform of trigonometric functions. We proved Laplace transform of sine at. This was a upon s square plus a square. Similarly, Laplace transform of cos at was s upon s square plus a square. So we have calculated Laplace transform of 6 elementary functions, that is 1, t, t raised to power n, e raised to power at, sin at, cos at. Today we are calculating the Laplace transform of hyperbolic functions, that is sin hyperbolic at, sin hyperbolic at, that is sin at. Similarly, we will calculate Laplace transform of another hyperbolic function, that is cos at. This we'll have to calculate. So let us start. We know sin at is equal to e raised to power at minus e raised to power minus at divided by 2. Let us use this formula in the fundamental formula to calculate the Laplace transform of any function. As we know, Laplace transform of any function, that is f curly bracket start, close the curly bracket, and inside the curly bracket write down the function ft. Another symbol is f tilde t, also represented by fs. This is given by 0 to infinite e raised to power minus st ft dt where t is greater than or equal to 0. This was the fundamental formula for calculating the Laplace transform of any function. Now Laplace transform of sin 80 will be given by 0 to infinite e raised to power minus st. In place of function, we will have to write Laplace transform, that is sin 80, and the formula of sin 80 is e raised to power 80 minus e raised to power minus 80 upon 2 dt. Now, let us multiply e raised to power minus st by e raised to power 80. So we'll have half 0 to infinite e raised to power minus st was outside the bracket and e raised to power 80 was inside the bracket. That's why if you multiply e raised to power minus st by e raised to power 80, you will get e raised to power minus s minus a t dt minus half 0 to infinite. Again, e raised to power minus st was outside the bracket and e raised to power minus 80 was inside the bracket. If you multiply e raised to power minus st by e raised to power minus 80, you will get e raised to power minus is common inside the bracket, s plus a and t dt. So it is half. Now integration of e raised to power minus s minus at will be e raised to power minus s minus a t divided by minus s minus a minus. Similarly, integration of e raised to power minus s plus at will be e raised to power minus s plus a t divided by minus s plus a. Close the bracket and limits are 0 and infinite. Now we will put the limits, that is upper limit minus lower limit, and then we will calculate the Laplace transform of first hyperbolic trigonometric function, that is sin 80. Thank you.